Hello and welcome. This is a video on adding and subtracting polynomials. So if you're adding or subtracting polynomials, basically all you have to do is distribute the minus when you're subtracting and then combine like terms. Okay? So essentially all we're really doing here is combining like terms. Okay? Now, some people might not remember what like terms are. So let me talk about like terms briefly. So when I say combine like terms, when I say like terms, I mean terms with exactly the same variables raised to exactly the same powers. Okay? So it's going to be the same variables raised to the same powers. Okay. So combining like terms means you have the same variables raised to the same powers. And as long as they're exactly the same, then you're just going to add or subtract the coefficients, so the numbers in front of the variables. Okay? But an example is going to be helpful here. So let's do an example. Okay, so example. Here they say perform the indicated operation. Perform the indicated operation. Okay. So when they say that's just going to mean we're going to simplify. And of course, the way we simplify for these problems is we're going to add or subtract polynomials by combining like terms. Okay, so let's jump into an example. Okay, so for example number 1, we're going to be doing for example number 1, we're going to be adding two polynomials. So for this one, the first polynomial is parentheses 5x minus 2. And then adding, we're going to have 5x minus 2 plus the other polynomial is parentheses 7x squared minus 5x plus 9. Okay, so we have 5x minus 2 plus 7x squared minus 5x plus 9. So probably the weirdest thing here is the parentheses. Now when you're adding, you don't really need parentheses. Okay, so right off the bat, we can just get rid of those parentheses when you're adding. If you're subtracting, you would have to distribute the minus. But if you're just adding, go ahead and get rid of those parentheses. So I'm just going to cross those out. We don't need those because we're just adding. Okay, so really we just have 5x minus 2 plus 7x squared minus 5x plus 9. Now what we have to do here is we've gotten rid of the parentheses, so now we simplify by combining like terms. So what are the like terms here? Well, I'm going to use different colors and symbols for each type of like term. Remember, to be like terms, you have to have the same variables raised to the exact same powers. So here, the like terms are going to be x squared, x, and then the constants. And the constants are the ones that don't have a variable. Okay? So we've got a 7x squared, and then we have a 5x and a negative 5x. And then the last type of like term there is a negative 2 and a positive 9. And of course, if you only have a pencil or a pen that's just one color, you can use these symbols underneath it like I'm using here. Use different shapes underneath the different like terms, and writing it below it like that helps you to just kind of combine them a lot more easily in your mind because you're only combining terms that have the same shape below. Okay? So there's only the 7x squared, so there's nothing to combine that with. So we go ahead and just write the 7x squared. Now the 7x squared is the highest power, so we write that one first. And then the next highest power is going to be the 5x minus 5x. But combining those coefficients, 5 minus 5 is 0. So these two just cross out. Alright, so we're not actually going to have any x's left over. And then the last type of like term is the constants here. So for the constants, negative 2 plus 9 is going to give you positive 7, because 9 minus 2 is 7. Okay, so we have plus 7 here. And that's actually going to be our answer. Our answer is going to be a polynomial. So if you're adding or subtracting polynomials, your answer is going to be a polynomial. Okay, so I know it's a bit strange because normally people would solve for x. That's what they're used to doing. But here, you're just combining like terms, essentially, and that's it. Okay? Now, for the next example, I wanted to do an example of subtracting polynomials. Okay? So for example number 2, let's try subtracting polynomials. Now in the directions, they're still going to say perform the indicated operation, but that just means add or subtract as indicated. So on the first one we were adding. On the second one, now we're going to be subtracting. Okay? Alright, so for this one, we have, for our first polynomial, we have parentheses 7x plus 6. Okay? And then for our second polynomial, we actually have minus parentheses negative 4x squared minus 8x plus 6. Okay, so minus parentheses negative 4x squared minus 8x plus 6. So as you can see, this is subtracting polynomials, not adding them, because there's a minus out front here. And subtracting polynomials has one extra step. So when you're adding, you just get rid of the parentheses and then you combine like terms. If you're subtracting, however, you need to distribute the minus first. So first step is to distribute the minus. Distribute the minus. Okay, and of course there's only a minus in front of the second polynomial, not the first polynomial. So we're only going to be distributing it to the second polynomial. But you have to distribute it to each term, not just the first term. Okay, so here we're going to distribute the minus to all three of those terms. And when you distribute a minus, all that does is it switches all the signs of that second polynomial. Okay, so that just switch the signs. We're going to switch the signs. Okay, so right now it's minus, minus, plus, but after we distribute it, those signs are going to switch. So it's going to become plus, plus, minus. Okay, so kind of focusing on that second polynomial, now we're going to have plus, plus, minus. So we're going to have positive 4x squared, positive 8x, and then minus 6. But the first polynomial didn't have a minus in front of it. So for that one, there's no minus to distribute. So the first polynomial is still going to be 7x plus 6. And after you distribute the minus like that, you can go ahead and get rid of the parentheses, because at that point, then you're just adding. So it's just like the last problem now. Okay? So when you're subtracting polynomials, it has one extra step, which is distribute the minus to the second polynomial at the beginning, but then the rest of the problem is just combining like terms. Okay, so just like on the last problem, we're going to combine like terms. Combine like terms. Okay, so here our like terms are going to be, well, let's see, we have a 4x squared by itself, and then we have a 7x and an 8x, and then for the constants, we have a 6 and a negative 6. Okay, so those are the exact same variables raised to the exact same powers. You can't combine anything with anything else unless it's exactly the same variable raised to exactly the same power. Okay, but now we just add or subtract the coefficients. Okay, and the coefficients are the same as the numbers in front of the variables. So we have a 4x squared by itself. That's the highest power. So there's nothing to combine it with, so we write 4x squared first. Okay, and then the next highest power are the x's. That's actually x to the first power. And then 7x plus 8x is going to be 15x. So we're going to have plus 15x. Okay, and then the smallest power is the constants. They don't even have a variable. And then 6 minus 6 is 0. Okay, so we have plus 0 here. But of course, any number plus 0 is the number. So we don't write plus 0 in our answer. So I'll erase that. Okay, so our answer is going to be 4x squared plus 15x. Okay? Pretty cool, huh? Okay, so I think I want to just do one more example. These don't get too difficult for the most part in your homework, so hopefully you won't struggle with them too much. But for my third example, I wanted to do a little bit harder one. So for this one, we have parentheses, negative 12x cubed minus 7x. Okay, that's our first polynomial. And then we have minus, so we're subtracting. And for our second polynomial, we have 3x cubed plus 5x minus 11. Okay, so we have, for the first polynomial, negative 12x cubed minus 7x. And for the second polynomial, we have 3x cubed plus 5x minus 11. And here we're subtracting. We notice there's a minus between the parentheses. So we are going to have to distribute that minus to the second polynomial as our first step. Okay, so we distribute that minus to each term of the second polynomial, and all that does is switch the signs. So originally the signs were plus, plus, minus. So now they're going to be minus, minus, plus. Okay, so we're going to have minus 3x cubed minus 5x plus 11. Okay, and then for the first polynomial, of course, there's no minus to distribute, so we just get rid of the parentheses. So the first polynomial is negative 12x cubed minus 7x, negative 12x cubed minus 7x. Okay, so we have negative 12x cubed minus 7x minus 3x cubed minus 5x plus 11. So that was the distribute the minus step, just like the last problem. And then, of course, all we have left to do now is combine like terms. So what are the like terms in this problem? Well, we actually have the highest power is going to be x to the 3, or x cubed. Okay, so we have negative 12x cubed and negative 3x cubed. That's the highest power. And then you'll notice in this problem we don't have any x squared, and that can be true sometimes. So our next highest power is the x. Okay, so we have negative 7x and negative 5x. Those are like terms. And then the lowest power that we see here is the constants. And there's actually only one constant here, which is the 11. And look, it made a smiley face. Okay, so combining the red ones, we have negative 12 minus 3 is negative 15x cubed. Okay, so we have negative 15x cubed. Because remember, if they're the same sign, you keep the sign and add. So 12 plus 3 is 15, but they're both negative, so it's going to be negative 15. Okay, and then we do the same thing with the x's. Those are the other like terms here. So negative 7 minus 5 is the same sign, so we keep the sign and add. 7 plus 5 is 12, so we're going to get negative 12x. Okay, so we get negative 12x. And then the last thing is our smiley face here. That's the 11, but there's nothing to combine it with because there's no other constants here. So we just write plus 11 last. And notice with these, I always write the highest powers first. That is important, as I mentioned in one of my other videos on polynomials. Okay, and that's it. Thank you for watching.